You're listening to the Banana Data Podcast, a podcast hosted by Data IQ. I'm Triveni.
And I'm Will.
And we'll be taking you behind the curtain of the AI hype, exploring what it is
and what it isn't
capable of. On this episode, we're asking, what is AI? And how complex does it need to be to qualify as such?
Triveni, I wanted to talk to you today about AI.
Don't we talk about that every week, Will?
Exactly. We do talk about that every week. So the reason why I wanted to talk about AI today is exactly for that reason. I felt like we spend a lot of time thinking about data science, machine learning, artificial intelligence, foremost amongst these big, heavy topics. And I wanted to try to take a full episode today to distill that a little bit. What does AI actually mean? What qualifies as AI? What doesn't qualify as AI? How do you define it? How should it be defined? I think if we can do this well, we'll be doing our listeners a service. So that's my hope for today's episode.
I think that's right. I think we need to, as a sort of collective, right, out there in the AI data science space, really figure out what do we mean by certain terms. I think what happens is that the term AI, data science, machine learning, they all get kind of thrown around. And people like to say that one is a subset of the other, but then we talk about it as if they're all the same sometimes. So I agree with you. I think it's an important topic. Let's dig in.
So I guess starting at the top, when I say intelligent, what do you think?
I guess it means being able to take something in, evaluate it, and create some sort of output.
That was kind of the definition I'd come up with in my mind in preparation for this episode as well. I mean, I think, stimulus corresponds to output, and that stimulus is processed in some intelligent way. I think a key idea I'd like to convey during this episode is that the processing of inputs can be really sophisticated. So we think about neural nets are these crazy, beautiful, complex mathematical algorithms that take in a wealth of data. They do all these transformations to the data, and then they give you out some quote unquote super intelligent output. Like that to me qualifies as artificial intelligence, but also simple decision rules also qualify to me as artificial intelligence, right? So if you're a bank way back when and you had some simple heuristics as to when you approved or denied a loan, like if so-and-so's income is below a certain threshold, deny a loan. Like to me, that system, if you want to call it that decision rule is intelligent. Am I off base here?
I don't know if you're off base. I just don't know if AI is the right term. Artificial intelligence is the right term for what we're doing. So I want to take a second and review how we got even to the term AI, right? So for those of you who are dedicated fans, you'll remember that we talked about the concept of AI winters on a previous episode. And essentially the idea is that AI as a term didn't really come to exist until 1956, right? And this was developed back in the day as sort of thinking about robots and machines that could actually do work. So artificial intelligence, artificial human intelligence, right? And then we went through these various winters where AI development sort of fell off. And now we've gotten this resurgence thanks to big data computing and processing power, storage power. And now we have advances in deep learning and neural nets. And so AI has become this thing again. But for me, the term AI doesn't actually describe what it is most people are doing in the space.
Yeah, agree with all of that. I think to that point, I actually wanted to bring up an article for our conversation today that was written by none other than Florian Douetteau. The article is called, "Is it AI or Not?" And so this is something, in full disclosure here, Triveni and I are Data IQ employees, and Florian is our lovely CEO. And he wrote this really helpful article, I think, that talks about whether or not someone's doing AI. And so the argument that I think Florian makes that I agree with is that AI is broad, as I was just discussing, right? Simple decision rules, I think you could qualify kind of as AI, or something more sophisticated can qualify as AI. But what Florian does, which I think is quite helpful, is he creates, and we'll put a link to the article in the show notes, what he calls the AI scoring matrix. And don't worry, the term matrix I know has scary connotations as well, maybe for our listeners, but rectangle, you can think of it as. And so Florian breaks down AI along 4 different dimensions and then has potential scores for each. So the dimensions, as he articulates them, are perception, learning, interaction, and complex decision making. In general, sticking with the first one, this concept of perception, I like what Florian has to say here. He basically differentiates and says, if you have some application that reads in single records or like flat CSV files, so Excel files, that's just a common data file type that individuals might work with. That's kind of a less sexy, less highly perceptive AI application if you're just reading in data tables. Whereas, he qualifies as more perceptive an application that takes things like images or speech or text as input. And so I think that's a useful delineation to say, hey, if you just have a simple CSV file that you're using as input, that's maybe a lower level of perception, but it's still an intelligent system. Whereas today, I think what many of our clients are working towards are these very intelligent systems that can deal and can perceive kind of more complex data types like speech, like images, like video.
Well, I don't think that everyone needs to be perceiving those things to be making use of AI. I think this is where I take issue with the term AI in general, because we make it sound like it's artificial intelligence, so it should think and act like a human, right? It should be able to do things similar, right? So there's a neural net behind it. It can take your input of like a video or an image and say, oh, this is a dog, this is a cat, whatever. But even if you're reading technical data, flat files, whatever it might be, there's still decision-making happening that is valid and valuable, right? Even if it's not a robot. And so I think the term artificial intelligence I find it too broad. And as a result, people keep trying to push towards some like futuristic, cool AI and ignore what is like low-hanging fruit of like very good, interesting data science questions that can immediately give them value, but isn't necessarily the coolest thing.
Yeah, and I think if there's one or two takeaways from this episode, I think one I would like to be that intelligence can be broadly defined and artificial intelligence can be broadly defined. And then the second is a point that I perhaps now attribute to Jeff McMillan, who's the chief data officer at Morgan Stanley. He says, AI should not be your goal. So it's simple, it's a catchy phrase, but it makes so much sense. And I think it totally is in line with what you're saying. And so going back to Florian's 4 dimensions, just because your input is video files as opposed to an Excel spreadsheet doesn't mean that you're necessarily getting a better impact for your business. And that's what Jeff is saying. AI shouldn't be your goal. Your goal should be to help your business, help your customers, help the world, and not design or over-engineer some algorithm, some data input.
Yeah, and I think that's the right way to think about it, because moving away from the idea of like AI means robots and chatbots and terminators towards AI is actually using interesting data or good data to create value opens up the field to a lot of people who might have thought, oh, I can't, my company is not ready for this, or our business line is not ready for this. But in fact, it is. You have data everywhere. We are constantly collecting data now, as we've talked about in this podcast, right? So I think we need to move away from the original meaning of AI, right? The one that they came up with in the 1950s of all these complex human-like intelligence systems, and recognize that artificial intelligence doesn't have to be a mimicry of human intelligence, right? But it can be its own set of intelligence that uses maybe less complex data, but still provides a huge amount of value.
And again, for anyone listening to this who's thinking about how they're using data to enable their organization, another guideline here that I think is underrated is that decision rules are super powerful. And if you can use a decision rule, don't try to do AI or machine learning. So again, by decision rule, I mean something that's hard-coded by an analyst, which says, hey, very often in this organization, when we see X, we do Y. Or 100% of the time, when we see X, we do Y. And if that simple heuristic, that simple decision rule that you can implement in your organization adds value, that's great, because you're saving so many resources. It's not that hard to implement. It's interpretable. There's a lot of good that comes from a decision rule like if X, then Y.
Yeah, absolutely. It's important not to get caught up in sort of the hype cycle.
Don't over-engineer.
Don't over-engineer. Right. This is kind of what we heard from Dan when he was here from Twitter, telling us that don't make things more complex than you need to be, right? Occam's razor. If you can do it simply, you should do it simply. Otherwise, you, one, get yourself into a lot of technical debt, and two, you spend a lot more resources on something that isn't necessary.
Yeah. And so I think, again, another point that Florian makes around simplicity and decision rules versus, learning algorithms, something else, I think one of the themes of this episode is trying to dispel myths. And one myth that I hear thrown around a lot is people, they want, AI that continuously learns.
Right.
And so this is not impossible to achieve. But again, Florian breaks it down. He thinks about kind of the frequency and the, not to use an overused term, but the intelligence of your AI system's ability to learn. So a simple decision rule, it's not really learning at all. Someone's just giving it information that it's then putting into practice. Whereas we've talked before on this podcast in our more wonky days about things like gradient descent and how you can take a mathematical model and fit it to data. And so in that case, I think to me, that's what I think of when I think about machine learning. But then, furthest along this dimension of sophistication in learning, I think is the concept of continual learning. And so we've talked about reinforcement learning before. In general, there are ways where you can build a system that responds to input in real time and uses that real-time input to adjust mathematical parameters. Sorry, we're getting down in the weeds here, but really that's all these algorithms are. They're numbers. So this input comes in, and in real time, in response to that input, you change the numbers that are your mathematical model. That's continuous learning. But I think so often people who say that, they don't really understand that these algorithms are numbers, they're parameters, they're algorithms. And so if you want some intelligent system that continuously learns, kind of going back to previous conversations again with Dan and others, a lot of it needs to be intelligently engineered. So if you want to have a system that continuously learns, you're going to have to put in the work ahead of time to not only train the initial algorithm, but to also design an intelligent system to make your organization data powered. And that's complex too. So again, if you can be simple, keep it simple.
Right. And I think the thing about continuously updating a machine learning algorithm, it's one thing to say, okay, we got a new set of data because we have like this whole like slew of data that just came in from our most recent customers or something. So we're going to retrain the model with that new data so that it's updated. That's one thing. But continuous learning of constantly taking in an input and updating isn't really applicable for most industries.
Do you need a model that's being changed every second?
For the most part, behaviors are going to stay the same. It's only over a long period of time that you see a change in behaviors, maybe as a result of your machine learning model, and then it does need to get updated, right? That's where you look for data drift and model drift. But updating every second, is this person going to get a loan or not, isn't really a good use of anyone's time in that sense.
I think that's a great point. And that's something where, again, you need to think about what's the point of your model to begin with. So if you're trying to model what I will like to purchase, so even though I will, hopefully, as a semi-intelligent human being, am learning constantly, I'm out there in the world being exposed to stimuli and my brain's changing, the substantive ways in which I buy, like I still like jeans tomorrow, even though I'm a different person tomorrow than I am today. So Levi's doesn't need to come up with, a drastically different marketing strategy towards me. They don't need to reinvent the wheel overnight, even though the person they're trying to market to, has changed. So I think that's a really interesting point.
And now it's time for In English, Please, the part of the show where we explain complex data science topics in English. So, Will, can you explain to us what is an API?
Yeah. API stands for Application Program Interface. And so this term is thrown about, I think, way too often. It kind of has now several convoluted meanings, but the one I want to focus on today is the concept of an API, for example, for machine learning model scoring. So what does this mean? Imagine you're Levi's and you're building a machine learning model to recommend various Levi's products to users when they come onto your site. Seems like a pretty kind of standard machine learning or AI use case. And so you do a bunch of work, you build some machine learning model. We're not going to talk about that right now. But what happens eventually is you have something which is a mathematical model that predicts, given some inputs, this person's going to like this type of gene or not, right? That's kind of the big paradigm here. Data comes in, the model does some thinking, it produces some intelligent output, which is Triveni will like these genes, Will like these different genes. And so in this case, what the API is doing is it's running as a particular service that Levi's has, wherein when certain data goes to that API service, other data, namely the model response, is returned. So if I log into the website, Levi's presumably knows something about me because I have a Levi's user profile. They take my user profile data, they send my data to the API, the model that lives at the API, and in return, the API says, hey, given this data, looks like this is Will's profile. We think Will's going to like these blue jeans. And that's really as simply as it is. An API is a service that takes input data, processes it, and returns output data.
Thanks for explaining that in English. So back to what we were talking about earlier, and maybe in line with what I've been trying to argue so far, there's an article by Forbes that's called AI is not just for big tech, right? So the argument here is that Facebook, Google, Amazon, they're doing all these crazy things with chat robots and recommender systems and predictive text. And that's all very interesting, but that's not all AI can be, right? I think the point that this article is making and what I'm trying to say is that the term artificial intelligence doesn't necessarily mean only this advanced, really cool, complex decision making. It can also mean very practical things, right? Like I have information on my customers and how long they spend on my website. And based on that, I can predict if they're going to buy something or not. And based on that prediction, I can then update certain things or make changes to drive value. And that in itself is AI too.
Yeah, I think organizations like Facebook or Amazon, I think of them as very digital native. So they've been collecting rich data from their inception. And as a result of that, I think they've done a good job to align their business model with data-driven tools like machine learning algorithms or AI. Therefore, I think it's incumbent on non-digital native organizations, so people who've been around for 50 or 100 or 200 and more years. These are great businesses that have clearly found a way to serve their clients and serve their customers well. But I think what they need to do to make sure that they're staying relevant is just think more rigorously. And again, it's a point we've made often about data collection. Because if you're trying to use a highly intelligent AI system to improve your business, you do need some data. And so if you're not thinking rigorously about data collection, then you're not going to be doing powerful AI. And, you might be falling behind as a result.
Yeah, definitely. The data-driven side of this, I think, is actually what should matter in these conversations around AI, right? It's not the intelligence that's the important part here. There are algorithms, there are packages, there are libraries to do all of that. If you don't have good data, if you're not actually collecting data with an eye towards using it in a meaningful way, your artificial intelligence is going to be dumb.
Yeah, I mean, a risk here, I think, in the venture capital community, there's this tendency to say, what is this new technology? Maybe we don't fully understand it, but we're excited by it. We know enough to know that it holds great potential. And then we start throwing resources at it, and it becomes a self-fulfilling prophecy. And suddenly, again, going back to a point we've made previously, people are doing AI for the sake of doing AI. And so really, what's the whole point of AI? As far as I can see, the point of having an artificially intelligent system, it's serving some human well, and it's serving some human either better than another human could or more efficiently than another human could, right? And so if those two things aren't at the forefront of your mind the entire time, and instead you're just making a company that's a blockchain AI-powered company because you think you're going to raise a big seed round, that's a problem. And yeah, I'm being a bit tongue-in-cheek, but I do think there's a serious issue here.
Yeah, I mean, again, it's all part of that AI hype cycle of like, well, so-and-so's doing it, so we should be doing it, or so-and-so says we should be doing it, so how do I do it, right? And coming up with these use cases or ideas that don't actually resonate with what a business needs. And, when you think about it, so I tried to come up with some just common use cases for this episode about, okay, what is a common AI use case? And I realized that what we want to think about as AI of like chatbots and the like isn't what is commonly being done. There aren't quote unquote sexy AI use cases in the real world. What's happening at the most common level are very ordinary things that have huge impact. So predicting customer churn, predicting how much a customer might spend and adjusting UX design accordingly, looking at maintenance of machines in manufacturing, being able to say, okay, we can tell that, machine A is headed for a breakdown. We should probably repair it in advance or replace a part in advance. That kind of thing isn't going to break headlines, but it's so valuable.
It is valuable, though I think it's somewhat depressing in that if I had to guess kind of the largest use case for AI writ large, I would think about sales and marketing. Mm-hmm. And all the love for my people in sales and marketing. However, I think in large part, it's just because we have a regulatory system in place and we have an economy in place where getting actionable data related to the sales and marketing process is easy. There's money to be made. So therefore, organizations have gotten really sophisticated at using AI to help with their sales and marketing practices. I would like to see, it's early January 2020, so I'll look forward to the upcoming year. I would like to see this year and beyond, right? We need more data. We need more organized data, and we need more accepted data use practices for data that's not just related to sales and marketing. So one I always come back to is health, right? There's so much biometric data that I emit, but like who has it? How do they use it? How do I maintain my privacy while also allowing people to use data about my body and my health to benefit me? If we could figure that out, I think the world would be a lot better place.
Well, that's interesting you bring that up because I wanted to make sure that in this conversation about what is AI, we also talk about the responsible AI part of it, right? And so it's very easy for us to say artificial intelligence are these machine learning models that are using your data to create value, and it's great. But that sort of explanation leaves out the human in the loop, right? And it's only through the human in the loop where we can actually make sure we're doing the right thing with our data. We're ensuring privacy. We're ensuring less harm overall. We're not letting biases creep in. And I think when an organization thinks about artificial intelligence, they think, okay, I need to hire like 3 really like advanced PhDs in artificial intelligence and machine learning, and they'll take care of this for me. When in fact, what they need to do is enable their people who already know the data and the industry very well to start extracting more value from that.
Yeah, and I think responsibility is good. It's great. It's very important. And then also in a somewhat self-serving way, I think there's also just this concept of a delightful experience. I mean, are you familiar with the company Dropbox?
I am.
Yeah. Did you know that one of their core company values is cupcake?
What does that mean?
So cupcakes inspire delight, which I think is true. I find cupcakes delightful. And so Dropbox, I think, did a great job at making a delightful user experience. And so when I speak with people about building AI applications, I oftentimes, to your point, emphasize the need for a human in the loop. A, because it's responsible. It's a good thing to do. You want to make sure that your algorithm is not going off the rails. But also, though we've made a lot of progress, I think machine learning algorithms, their performance in this day and age still leave a lot to be desired from the end user experience. And so if you want to make a delightful user experience for your customers or for your clients or users, I would encourage you to supplement AI with human in the loop. Because if you don't have that, people are just going to be angry that you're trying to over-engineer a solution and it's just not working.
Right. Yeah, I think the point here is that artificial intelligence is only as good as the real intelligence that gets put into it. Right. And so if we're saying that, oh, I need to do AI and I'm just going to like throw a bunch of data at a neural net and now I'm advanced and I created an artificial intelligence system, but you haven't put any of like the sort of the strategic thinking and planning behind it, it's really not good AI. I think what I want people to get out of this conversation, right, is that one, we're kind of already doing a lot of AI. Things that we think are mundane or ordinary are actually advanced AI techniques, right? Predictive maintenance, customer churn, very simple tasks, marketing and sales stuff. These aren't things that were happening 25 years ago. So we're already in the future. But if we want to move further, we have to remember that we, the humans, are a key component of the next generation of AI. And the next generation of AI doesn't mean robots taking over and doing our jobs. Okay, before we head out, time for facts that are bananas. Will, I don't know if you're a gambler or not, but if you go to Vegas to play poker, your odds of getting a royal flush, which is, one of the best hands in poker, your odds of getting a royal flush are exactly 1 in 649,740.
Don't bet the farm on that. That's all we've got for today in the world of banana data. We'll be back with another podcast in 2 weeks, but in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Triveni.
It's been great, Will. See you next time.